Hello everyone, reporting today for Fun Robotics Network. I'm Abhas, and with me here is Team 18270 RoboPlayers from Irving, Texas. They were recently the Inspire Award winner at the First in Texas North Regional Championship, and perhaps more importantly for this Behind the Bot, they're currently ranked 7th by non-penalty OPR in the world with the number 4th teleop. They have one of the best intakes I've seen in Into the Deep. It is super fast. They had a 283 2v1 score, just all around awesome team. Can't wait to get into it coming up on Behind the Bot. Alright, RoboPlayers, so I think every season you guys just have one of the fastest robots I see. Just like every subsystem is just super optimized. So talking about your drivetrain briefly, is there anything you think that's like really important there that allows you to maintain such speed?
Yeah, so our drivetrain is built with 1-to-1 on 435 RPMs. We have a gear on our each one of our drivetrain motors, which is actually used for our PPO. So it's just regular grip force wheels, and it's just HD5 belt.
Cool, yeah, and with that 435 RPM, so obviously it's really important to be light, when you have such a fast ratio. How heavy is your robot as a whole?
Our robot's like 22 pounds because we use full carbon fiber.
Wow, yeah, that's awesome. Now, jumping right into that intake, that's kind of one of the biggest reasons we wanted to talk about you guys. I see those massive gears at the bottom. Can we start with that and then walk me through the intake design as a whole after?
Yeah, so pretty much the way our intake works is that we have a bare motor here, which is connected to one of those servo CD gears, and then we have two bigger gears here that basically drive each other, and then they're connected to this bare motor gear. And so pretty much whenever the motor spins, both of them automatically spin in opposite directions. And then also the tubing here is belted to the gondola at the back, which helps bring in the ventals.
I see. And so with that, like, was this a system you had started with all the way from day one, or like did you start with a servo, then you upped it to the bare motor? Walk me through the progression there.
Yeah, so our first version was actually very similar to this. We had a bare motor with the same layout basically, except throughout the season we iterated upon it, and then we added the top roller, which helps bring in samples much more quickly.
And yeah, before we get into that top roller, one more question there. So like obviously weight was a big concern for you guys, and I've seen a lot of teams use like either Axon servos or like the Melonbotic Super Servo to make their intakes lighter, but you guys went straight for the motor. Why?
We just liked the extra power that our motor gave us, and we just wanted to have fast intake. We tried a Super Servo last year. It wasn't that good. We weren't able to get that much power out of it. So we just wanted to go for a motor in order to have the fastest possible.
Cool. All right, so let's jump into that top roller, and we'll go through the rest of the intake path after.
On our front tubing, we have directly mounted to our Axon bevels, which slow it down, but then we have a belted speed increase. So we slow down and we speed back up in order to get the same speed. So both of these, the top roller and the side rollers actually move at the same pace. So that's how we're able to transfer from this point to this point.
Okay, very neat. And as far as kind of dimensioning goes for all of these components, because of the flexibility of the surgical tubing, was that not really something you had to tune, or did you find that you had to tune these dimensions and like the distances between the tubing and like all of those factors a lot?
We mostly just guessed, and then I think we got it right in like the second or third try.
Okay.
Yeah.
Okay.
Too much cheating in that. Yeah.
Cool. Yeah, and we'll have a bunch of B-roll also showing your intaking, but can we also see it on screen here and see what that path looks like? It's just, yeah, pretty much instant. All right. So as far as like jams and things like that go, how did you ensure that the sample would always be oriented correctly? Like, were there any small things that just really elevated how it worked?
I think the biggest thing was the actual addition of the top roller, because originally what was happening is that the tubing would actually keep the samples out, but then with the top roller we're able to like reorient them back inside. So that was able to like increase the range, even though it's just in the front.
Okay, yeah. Last question I want to ask about your guys' intake is when it comes to collecting samples near the walls of the submersible, how do you guys do that? Is that something you face challenges with, or yeah, just talk about that in general.
Yeah, so for us, dropping samples that are like against the perimeter of the submersible are kind of hard because like of how long your intake goes. So even if we're all the way up against the submersible, we're not able to get it. Um, so you have to go like at a different angle to try to get it. But it hasn't been too much of a problem for us so far because there've always been more samples. But I just don't know how that's gonna go in Worlds or something.
Okay, yeah. So like, come Worlds, is that where you would look at adding some sort of sweeper mechanism, or what are you thinking there?
Currently, we don't have enough servos for another sweeper mechanism because we use. Currently, we have. We were planning on adding level 3, so that would be an extra 2 servos. But right now, we're at 10.
Okay.
So we wouldn't have any more.
All right. Well, yeah. Let's go through those 10 servos real quick, and then we'll go into the deposit.
Yes. Okay, so we have 2 servos for the take flip right here. We have a axon micro for our slash. We have 2 servos down here for our PTO. So get that. And then we have 5 servos on our outtake. So it's a claw here, 1 for our wrist, 2 for our flip, and 1 for our rail. So this is total 5 servos, and it's all on a servo hub.
Wow.
Right.
Okay. Pretty interesting. Okay. So with that servo hub, you're only running the power and ground, the power, ground, and RS-485 down into the control hub. Is that correct? Okay. Very neat. And one more question about the latch there. So is that also sensorized, or how are you using the latch for the intake?
So whenever we intake, our latch is always closed, and the only reason it would ever open is either to transfer whenever it retracts, or if we get a wrong color sample, it just flips back and then we need it to spit it out.
Very neat, very neat. Okay, jumping into your transfer sequence now. Walk me through that, and then we'll get into your deposit.
Okay, so whenever we intake, it's like this. So when we retract, we bring up the lid and we retract. This claw's open, but it comes in like this. So it really fits directly into our claw.
I see.
And our claw just needs to close, and then it'll come like that.
Okay, cool. Yeah, and now talking about your deposit, how has it changed throughout the season, if at all?
Yeah, so for our version 1 robot, we originally did not have this horizontal rail. We just had a longer arm, so that we pretty much were forced to. We could do this. So when we scored samples, it was out here. When we scored specimen, we were barely able to reach the bar. So for this design, with full carbon fiber, we actually added a rail. So now we can now pretty easily reach the bar, and we're able to score samples from the back pretty easily.
Okay, yeah, and so with that kind of string pulley design for the horizontal extension, why go with that instead of a linkage or some other mechanism?
So for our horizontal rail, we just wanted to make sure that we had linearity because we didn't want to have linkage. We just wanted to be able to set positions every time, and we felt like a linkage would not give us the accuracy. So it was just like, if we make a small change, we know exactly how much it is doing with string. For a linkage, it's not like exact, because if you're like close to over center, it's for each degree rotation of the servo, the rail actually moves less. So it's not as reliable, or we thought of it as a little bit more difficult to like tune and optimize because we can't just set exactly halfway the vision of the servo.
Got it, yeah. Now, talking about lift speed a little bit, your lift is extremely fast. Walk me through the actuation system, how many motors, what ratios, any counter springing. Tell me about all of it.
Yeah, so for our lift, we actually use 2 bare motors, and we use a Robotics 14-tooth pulley. And this is belted onto our main shaft, which is right here. So that main shaft is basically connecting both of our motors, and that main shaft also holds both the two spools. So each of those spools are 16 millimeters in diameter, and it's small enough that that at the high RPM that our motor that the shaft runs at, it still takes so pretty fast. For our counter springing, we use surgical tubing right here, and it's not the optimal solution, but it's still enough to speed us up and then make our cycles faster.
So are you stringing only one side of your lift and then counter springing the other side?
We're stringing both sides of the lift, and we're counter springing just one side.
Okay, I see. But okay, I see the string on the other side as well. And then for your retract, is that like a single retraction in the middle, or how does that work?
For our retract, we have two retractions, but we just felt that we had to make sure that since we have such a small spool, our string was wrapping over itself a lot. So we had to make sure that it wouldn't before with it actually being tight, we weren't actually able to go down all the way. So we had to release the tension on this a little bit.
Also, because the two sides are linked, both on the same shaft, and the spools are connected, one side stays a bit higher than the other because of the tension. So we just kept the tension very minimal in order to minimize the amount that this side sticks up.
I see. Okay, now talking about your hang, you've mentioned the PTO a bunch of times. So walk me through the mechanism you have going on there, and then I have a bunch more questions.
Okay. So for our PTO, we have a goggoless super speed that is connected to a linkage pretty much. So when our super speed just turns about 45 degrees, it's able to go from this position to this position, and then the gears and the gears on the motor, they engage, and then that transfers the power from the drivetrain to the single main shaft.
That is very cool. And so you're using all 4 of your drivetrain motors for your hang then, is that correct?
Yeah.
And when designing the system and speccing everything, how did you make sure that all of the speeds and stuff match up and you get that desired torque?
We kind of just match the speed, or we kind of match the torque of our version 1. So our version 1 was just 2 435s, because that was just the ratio of our spools, and we just unload those same motors. We just wanted to be able to match the speed match the torque, because we knew that we had a lighter bot than our version 1, and if we just kept the same torque, we'd still be able to hang, but we'd be able to go faster because of the increased power of the 4 motors.
Okay, got it. Yeah, that makes sense. And I think I saw another sensor in that area. We maybe hadn't covered it. Is that like a magnetic limit switch? What's going on there?
Yeah, that's the magnetic limit switch for our intakes. Whenever it comes in, there's a magnet here that is able to sense.
I see. And do you have a similar system for your vertical lift or only for your intake?
Yeah, it's the vertical lift magnetic switch is right here.
I see. Okay. Well, RoboPlayers, thank you guys so much. I mean, yeah, your robot is just super fast. I think the last thing I want to touch on is driver practice. You guys are clearly one of the best when it comes to that. Any advice for teams looking to improve their driver practice?
We just spend a lot of time per week, especially the week before the competition, and just doing driver practice and testing autos just to make sure they're consistent. And if anything breaks, they'll break in practice and not at the competition.
Okay, awesome. Well, thank you guys so much. Reporting for Fun Robotics Network, I'm Abhas, and this is Team 18270, the RoboPlayers.